Oh, hi. In your readings on the worksheets and in homework, we've been taking a look at an equation of state, as we call it. PV equals nRT describes a gas. P is the pressure. The units that we appreciate using for pressure are ATMs, or atmospheres. Very, very handy unit. V, volume. It's extremely convenient to use L, big L, for liters for our unit of volume. N is the amount. And the unit we use to count things, moles. So I'm going to put in a little MOL for moles. I'm going to skip R for just a moment. I'll put an arrow going up and say just a moment on that one. And then T, capital T, temperature. We need to use our absolute temperature scale, which is kelvins. If you're given a temperature in centigrade, the conversion factor is really quite simple to Kelvin. Kelvin is equal to your temperature in centigrade plus 273, 273.15 to 5 significant figures. We don't usually talk about degrees Kelvin, we just call them kelvins. We're all set to go. PV equals nRT, except for that new letter R. R is a constant. It has been determined experimentally over years and refined, and a number that we can use is 0.0821. And if you have another one that's been rounded a little differently, that's just fine. The units for this constant are liters times atmospheres over moles times Kelvin. And that's provided. Just know that, put it on a note card, probably on the front cover of the exam. It's on websites all over the place. We call it the ideal gas law constant. Solving problems becomes pretty ideal. We treat all gases the same, ideally. Krypton, carbon dioxide, oxygen, we treat them all the same and say that they occupy a very, very small volume. The gas itself. Let's solve a problem. A student obtains 50.0 moles of CO2 gas at 300 Kelvin. And that temperature is pretty close to room temperature. It's a little bit of, that's a little warm, 300 Kelvin, but it's like, somebody forgot to turn the air conditioning on an August day. 300 Kelvin. So the student obtains 50 moles of CO2 at 300 Kelvin. Here we are inside this room. Let's go ahead and say that the pressure is 1 atmosphere and 1.00 ATMs. What volume? Is this gas? Make a little picture of like a bulb. We go ahead and take this glass bulb and go ahead and fill it up with a gas. And let's say, for example, this bulb is flexible, like it could expand or contract. Very easy to do. We have ourselves a bulb, a balloon. A balloon is flexible, and it can go ahead and take a gas in and adjust its volume. Well, in this case, I guarantee you we're going to need a pretty big balloon for 50 moles of gas. Let's go ahead and make that calculation right over here. I'm going to write down our equation of state, PV equals nRT. And would you please examine this and decide what letter, what variable we're going to go ahead and solve for. Question's asking us what volume of gas. So we're going to solve for V. Rearranging this, we want V on the left side all by itself to solve, and that's going to equal nRT over the pressure. Let's go ahead and put in some numbers. N is the number of moles of gas, 50 moles of gas. R is the ideal gas law constant, 0.0821 liters times atmospheres over moles times kelvins. Temperature, conveniently described as 300 Kelvin. We don't need to do unit conversion on this. And the pressure, our room is very close to 1 atmosphere. I made it up in the problem, then it was 1.00 atmospheres. In just a moment, we'll take out our calculators and solve this. But first, let's see if our units work out. This constant has some crazy units. Things will work out nicely. Our moles cancel. We have moles up top, moles in the denominator, they cancel. What happens to kelvins? They cancel. What happens to atmospheres? They cancel. When we're finished, we're left with 1 unit, liters, and that's appropriate for the volume. Go ahead and take a moment and solve this, and I'll put my answer up in just a few seconds. We have 3 significant figures. Let me write down the answer on my calculator. But knowing we need to express this to 3 sig figs, let's call it 1.23 times 10 to the 3rd liters. 1,000 liters, that's a pretty good sized balloon. Nice job.